Hello there, good people. Just hang on a minute or two. See who else turns up. Just waiting for a few more people. Give it a minute or two. And then we will begin. So today what we're going to do is hit the topics on the topic sheet ready for your internal assessment. And if you're not sure where or when it is, it's on your normal lesson time on Monday in room 242. Unless you are my group and you see me period 2, you'll be in room, I think it's 133 or something like that. But it's a maths classroom anyway. So let's have a look then at some of the topics that we have today. And there they are. So everything that's highlighted in red is what you are going to cover in the topic list or the topic sheet. Number 2 over here, logical operations. I won't spend too much time on that. And that's because that comes up on every exam paper. You should be experts at that by now. I'm going to spend a bit more time doing the things that we've not done in previous revision sessions. So we've got operating systems, we've got modes of operation in there. We've got number 9, chapter 9 there, which is algorithms and programming. We have representing algorithms in a number of different ways. So that will cover pseudocode, flowcharts, that sort of stuff. And we also have in there as well programming constructs. So some things from your programming teacher side, modular programming, and that's the use of procedures and functions. Logical operations, again, that's covered over in chapter 2. Well, that's logic operations are things like and, ors, nots, nans, nors, exclusive ors, that kind of thing. Then we have scope of variables and the different types of scope that you can have, and also how to recognize scope in a piece of code or an algorithm. Hello, hyper, whoever you are. And then we've got parameter passing. What are the methods of passing parameters? What even are parameters? That's what we're going to look at as well. Then we'll look at systems analysis, which is also referred to as the software development lifecycle. And we're going to have a look at some methodologies in there, feasibility, a bit of analysis, which is also known as investigation, and we're going to drop onto testing as well. They're the main areas that we're going to look at. And then one that students tend to struggle with, program construction. Yes, compilers, interpreters, and assemblers are all forms of translators, and we're going to look at the different stages of the compilation process specifically. As always, if you do have questions, you can put them in the live chat, and I'll be sure to read them. How many marks is it? That's a good question. I think it is 60 marks. If I remember rightly, 60 marks. So if you look at IDs on there, which section is that covered in? So you can see there, software engineering, chapter 12. It's not highlighted. So, no. Now, always, okay, disclaimer. If I say we don't revise something or we do revise something, last time, the scandal that was truncation and rounding. Oh my goodness. Did I watch the end of that Liverpool game? No, I didn't. I was too busy preparing for this. So let's start then with operating systems and modes of operation. We'll jump straight to it. There are 3 types of modes of operation. The first being batch processes, and then there's 2 different types of modes of operation under the same heading, which is real-time transaction and real-time control processes. Now, when we say real-time, we're talking immediate input. Batch processing will happen over an extended period of time. So the images depict what I think of when I talk about these. So the first one, batch processes, is mainly large complex algorithms that are very repetitive, and they occur on mainframe computers. Real-time transaction is all about transaction and money, or monetary values and bookings and things like that. So that's why that one's in there. And then you've got real-time control processes. So getting immediate data to change and control something, whether it's hardware or software. Then, a couple of points on batch processing. So when you run a batch process, changes are stored in something called transaction files. So you've got two types of file here. You've got a transaction file and a master file. Transaction files are your smaller files, and they store things like your day-to-day, week-to-week, month-to-month transactions, and your master file is your records from whenever you started using the software or recording in files, for example. Now, I will give you an example of phone bills. You have a contract, you get every month, you pay a contract, or your parents pay a contract, and all your calls, text messages, etc. all get added up and put in a transaction file. Now, your master file will have every month's information from since when you started having that contract. Now, think about why we do that. A master file is quite a large file and it takes a long time to search, whereas a smaller transaction file with only the month's data in it is much faster to search. The only time we have to dig into the master file is when we're doing archival processes or someone has submitted a freedom of information request and we have to dig out that information again. Now, a batch process performs many similar tasks, one after another, and it can do hundreds of thousands of the same process, even millions of the same process. So like your phone company issues out your bill at the same time every month, it will do millions of bills throughout that month and send it to all their customers. If humans did that, there is a chance that there is potential human error in there, and two, humans are a lot slower. We are inferior to computers when it comes to repetition. So each job will only differ by the data it uses. So that's your data, things like your phone calls that are UK based, abroad, data that you've gone over your limits on, etc, etc. And I can timestamp it. Yeah, I'll do that for you. So there's no need for human intervention apart from actually starting the batch process off itself, and it's good for jobs involving number crunching and lots of repetitive tasks. And that's why we use mainframe computers, because mainframes are very, very powerful, large computers, and they're not the pretty little computers that sit on your desk and you can carry around with you. They are huge, look like servers. Now, batch processes, they can run out of office hours. So normally, somebody will start it at the end of the working day, come back in the morning, and all of the process should have occurred overnight. And that means there's a light load on the system, so it can just do what it needs to do, and it doesn't impact the rest of the people working in your company or organization. And finally, if any problems are encountered, they'll be put in an error file. And that means that the process can continue millions of times, and if it does come up with an error, it will continue. It won't stop. It'll put it in an error file and it'll move on to the next one and then carry on crunching, because there's nothing worse than going away overnight, coming back, and you've completed 5 bills out of 4 million. That would be a disaster. There is no donation. This is free of charge. But thank you. Now, a couple of advantages. There you go. So we said most of these before, but once a batch process has started, it will not require user involvement. Can it be run overnight? Yes, it can. Only serious errors would cause the batch process to stop. Like, when I say a serious error, I mean like the mainframe's on fire. Everything else goes in an error file. Now, it requires a large amount of CPU time, which is why we do it overnight. And it takes a long time to complete, normally a couple of hours. Obviously, if you have more jobs, it will take more time. These kind of questions vary from 3 markers to 6 markers, even to 8 markers. Just depends how many. It might ask you to also compare these two as well, or 3 different modes of operation. Then we move on to real-time transaction. I don't know if you were my favourite student. I don't know who you are. Yep. We don't need to actually cover the operating system's role in managing resources, because that's a different part of operating systems that we're not covering. But real-time transaction processing, so real-time transaction is real time. It's happening live in front of your face. So changes update the master file immediately. So when you're doing things like booking a seat on a flight, or even for a festival or a concert or something like that, records get locked. So no one else can book the seat until you release it. And normally when you're doing bookings for a cinema or something like that, you will have access to that seat to pay and to finalize your transaction for about 15 minutes. And then it'll say it will unlock in 15 minutes and you'll have to start again. And that's why when artists put tickets for sale, people jump in all at once and everybody's fighting to get these places. So they're just smashing F5, trying to refresh all the time. And this is what's happening. Real-time transaction is going on. Oh, my goodness. Ethan, yeah. Okay. The less said, the better. Now, if you book it, it updates straight away in the master file, so it's no longer available for anybody else. And that prevents double booking. And that's the main bonus behind transaction processing. So moving on from there, we've got real-time control processing. So this is used in what we call safety critical systems. And those systems are normally where we have a risk to life, human life. And if whatever is going on didn't happen, then it could return catastrophic results. And we've seen this in history before. So inputs are processed immediately and outputs are adjusted. And what this does is, because the computer can monitor whatever process 24/7, it doesn't get tired, it doesn't need a break. Computers can manage that, no problem. Accidents do get avoided. And some examples that you'll normally see in exams are things like temperature controls, water levels, the speeds of certain things, like a speed camera. So it'll continually monitor cars going past. If something goes over the amount, it will take a picture. Or in a greenhouse, if the temperature rises over 45 degrees, then it opens the windows, whatever. So the system can be automated with very few operatives monitoring. And that's why organizations like these kind of systems, because they're cheap. Don't have to pay a human to sit there. And when I say we've seen examples of this already, that is your example. Okay? You wouldn't write this in an exam. You wouldn't write Chernobyl in your exam. What you would write is you would write, a nuclear power station trying to cool down a reactor. If the reactor gets too hot, open the vents, let the seawater in, cool the reactors down, blah, 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 blah. That failed, and then that's what happened. Everyone had to leave. Yep, it is possible. I'll send them out a little bit later on after the stream, just like I did last time. So there we are. Another example of real-time control processing is normally aircraft control systems. So if you think about a pilot flying an aircraft on autopilot, the autopilot is taking in millions of inputs every single second, and a human just could not deal with that amount of input. So all these millions of inputs are being brought into the aircraft every second, and the aircraft makes adjustments based on the readings it gets. And it can react a lot faster than a human. Now, if a decision or action was made and it was delayed because of software running slowly, like in a nuclear reactor, it could explode, for example. So normally these computers, again, are very, very powerful. They have a very, very complex processor that can crunch numbers at a ridiculous rate. So there we go. Those are your three modes of operation: batch processing, real-time transaction, and real-time control. Okay, I'll come back to this one a little bit later on, because again, this is something we do. So let's have a look then at programming constructs. So there are three constructs at A level that you would come across. The first one being sequence, the second being selection, and the third one being iteration. So the first one, sequence, this is normally one that catches people out. And the reason why is because you just don't consider it normally when you're programming. Now what I've got here is a piece of code that talks about travel for Greater Manchester. This is a tram program that I made, and all it does is it has 4 variables, and then down here it just assigns the variables with an input box, and these are the questions that it asks. So it's expecting some kind of input from the user. So how is this sequence? If I say sequence, what I'm talking about is things go in order. So from top to bottom. So the first line that would be carried out would be we enter the class, then we carry out line 2, line 3, line 4, line 5, and it is not broken. The process of this is not broken. It goes one line after another in sequence. Even when we load the form, this is the event to load the form, it still goes in order from line 8 onto line 9, onto line 10, onto line 11. Again, the process is not broken. So that is an example in 2 cases where you've got sequence here and sequence down here. If you have an if statement or a loop of some kind, then that is where the sequence is broken, because it allows your code to make decisions and go down different directions, and that is not sequence. If we look at selection, a lot of people are comfortable with selection, but they just don't call it selection. This is the formal term for an if statement. Okay? And if you were to describe what an if statement actually is, you would say the if occurs, that's the keyword if, then you would have a condition, and if that condition gets interrogated, if it's true, you'll carry out, let's call this part 1 of your code, and if it's not true, you'll carry out part 2 of the code. And then you would end your if. So in code, what you're looking for, you might be presented with an algorithm, and you might get asked to state which lines a selection statement is on, for example. Then you would say, as long as you can spot where the if is, you can spot selection. And when you're having these conditions, you can obviously have logical operators in here. This is a logical operator here. This is and. And then you can have another condition. So remember, this is option 1 here, and this is option 2. So it allows your code to branch. This one over here is slightly different. This has another condition. So this has an else if here. Both of these examples are still selection, regardless if it has an else if in it or no. This could have no else if it wanted to and get rid of that message. But it doesn't matter. As long as you see the word if, then you know that portion of code is selection. Okay? If a question asked for an example, then you could, by all means, use this pseudocode here in the question. Moving from here, we have another series of selection statement, but this time it's a little bit more complicated. These if statements are called nested selection statements. Nested selection. And what nested means is a selection statement inside another selection statement. So, if I was to say to you, where does the nested if statement lie? Then what you'd look for is you'd look for an if statement, and then you'd look for another if statement inside it. There's no nested if inside there. There's no nested if inside there. There's no nested if inside there. But there is a nested if inside here, because you've got an if statement inside an if statement. So what this is doing, this is checking how many bottles of oil somebody buys. Then it's giving loyal customers extra bottles of oil, or it'll give a bottle of wine, depending on the choice of the user. So again, if you were asked about this, you would say, here's my example. If you have a condition, carry out part 1. Else, carry out part 2. Then in here, you'd have another if in here, and you would say, here's my second condition. And then you can carry out part 3. I'm just going to say part P3 because I'm running out of space. I really didn't think that through. Else part 4. Now, do you only need one if statement inside an if statement? No, you can have as many as you want. You can nest as far as you like. So you can have an if, inside 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 an if you really wanted to. The same process applies for our next construct, which is iteration. Iteration is basically repetition, looping. And if you think about the different loops that you've used, you might have done a do loop, a do until, you might have even done a proper do while loop, which is similar to the first one. You might have even done a static loop, which is a for loop, or if you've done pseudocode, you might have even done a repeat until. Okay, all of them are valid iteration statements. No problem whatsoever. Yep. If it asks you to show iteration, then if they provide an algorithm or some pseudocode, you can reference the number. It might ask you to spot that in the code, but if it asks you for an example, you'd have to do a pseudocode example. Okay, so here we've got a static loop. So it says for number equals 1. So number is assigned the value of 1 to 12. And what this is doing, this is just a multiplication. So you put in a number, whatever you want, and then it'll do the times tables for you up to 12. So it's going to repeat this line here 12 times. And that's iteration. And just like we saw before for selection, we can also have nested iteration. Again, all it means is you've got iteration inside another piece of iteration. You can have a for loop with a do while inside it. You can have a do while with a for loop inside it. You can mix and match any iteration statements you like inside each other. And you can have as many as you want. So this one says here, how many times tables do you want? So this will say outer number is 1 to whatever. So if I put in 12 here, it would do the 12 every times table up to the 12 times table. And then it would output them all. So this one is for the individual table, and this is counting up through all the tables. So you've got nested iteration in here, a for loop inside a for loop. There we are. So they are the 3 constructs: selection, sequence, iteration. And don't forget, for selection, you've got nested selection, and for iteration, you've got nested iteration. There we go. Okay. Now let's look at modular programming. So this really comes from your programming teachers and looking at procedures and functions. So we're at the point of the year where we would start heavily using procedures and functions, but you're going to have to talk about them in a theoretical sense rather than a programming sense. So looking at this here, a procedure is a subroutine. They don't return values, and really their job is to do only one thing normally. So they can calculate or they can display or something like that. Once you've called a procedure, you then return back to the position where you called it from. So for example, I could write a procedure called display inputs. Now you wouldn't know that was a procedure unless I put brackets behind it. Okay? And I can call that whenever I like, as many times as I like. So what is one of the main advantages to actually using procedures? And one of the main advantages is repetition. The reusability of code is one of the greatest weapons that a programmer has in their arsenal. Could be both. Could be both. If you're working an exam. Now, the difference between a procedure and a function is that a function does the same thing, but it returns a value. So a function is a subroutine that returns a value. Both procedures and functions can be passed information into them in the form of a parameter. So we're going to talk about parameters because they're quite important. So how do you know, or this here, does this need any information? If there's nothing inside my brackets here, there are no parameters. If you're a Python programmer, then sometimes these are referred to as arguments. Same difference. An argument or a parameter are the same thing. It's just whatever's put in between the brackets. So for example, if I was going to write a function to return a value, I might call my function calculate the VAT. And in the brackets, I could put the total cost. So let's say my total cost was £120. £120 goes in. I probably wouldn't have a symbol on there. £120 goes in, and then what gets spat out is the amount of VAT to be paid on that, which is £24, because we're 20%, aren't we? Practice makes perfect with pseudocode, but as long as you are able to explain it, you'll always get marks anyway. Now, what they can't do is I don't think I've ever seen a procedure or a function question that asks you to write a procedure or write a function. The only thing they'd ask you to do in pseudocode is tell me where the procedure is called, tell me where the function is called. And as long as you know that a procedure and a function have these brackets at the end of it, you can quite easily spot that this is either a procedure or a function. And you can this is what gives it away. Okay? So now, if we know that a parameter is something that gets passed in to be used inside the procedure or the function, there's two types of parameter passing. Where you're at in your programming skills is you're probably used to different types of scope. And we'll look at scope later on, but we've got local scope and global scope. But with parameter passing, there's something that's called passing a parameter by reference. Sometimes it's just referred to as by ref. Now, the key part to remember about passing something by reference is that the memory address is passed. So when you do your calc VAT and you pass in your total cost, if you're passing this by reference, you're not passing £120, you're passing the memory location. And if you pass the memory location, then what's going to happen is the computer can go and find the original data. And once it's got access to the original data, it can use it, but it can be edited. So when you pass by reference, the original data can be edited. And that is usually a bad thing. You don't want people to do that. So the general way of passing parameters now is by value. So if we were passing this by value, we would only pass in the temporary data 120. You can chop it, you can change it, you can do arithmetic operations, you can divide it, multiply it, either square it, whatever you want to do to it, do whatever you like. But the original variable of total cost, wherever it's stored in the program, still holds £120. You cannot change it. And that's because when you pass it in as a value, you create a copy of the data. A copy of the £120 variable gets passed in, and you can do whatever you like. And when you pass it in like that, it means it cannot be altered. So you can't mess up my program. And I definitely know that if I'm going to use the total cost variable again, I can do so without knowing that it hasn't been changed. And we don't get unwanted side effects like the value being changed by mistake because you've not tested properly. Okay, so to recap, parameters are passed in between brackets of procedures and functions, and there are two types of parameter passing. Passing by reference passes in the original memory address, and that means you can change it and edit in the original location. And then by value, passing a parameter by value creates a copy, and that cannot be altered. Now, the reason why I'm stressing this point is because I see students write correct examples for passing by reference and passing by value, but they've got them the wrong way round. And if that happens, we can't award you the marks. So remember, by reference is the address, by value is a copy. Okay. So if you look at this example here, here's for all our pseudocode people. Here is an algorithm. This is a typical exam question. And the algorithm calculates the area of something. So it says declare sub-procedure find area. So we know our procedure is called find area, and it has two parameters, a parameter R and a parameter A. Then it has some code annotation. This is a procedure to calculate the area of a circle. Underneath, it creates a variable called pi, and it's got the value 3.142. Then it starts the procedure and it says set the value A, well the value A is this one, to equal pi multiplied by R multiplied by R. And that's pi R squared, isn't it? So that's the calculation there that we're using. So it actually changes the value of A. Then it says declare subprocedure main program, declares a variable called area, declares a variable called radius, and then it says output the radius, output type in the radius, input the radius amount, call find area, so you call the procedure again, and you pass in radius, you pass in area, and output the area is, area, end the procedure, and then that's it, you start. So this bit's separate to the program here. Now what it's asking here is, it says explain why it's good programming practice to use constants, meaningful names for variables, and annotation. Well, not really relevant, but constants don't change throughout the life of the program. Meaningful names improves readability, and annotation in computer programs, that enables readability as well, because it allows us to understand quickly what the code is doing. But this second question is really what I'm focused on. From the above algorithm, identify a value and a reference parameter. Now you've only got two parameters to go at. There you go, R and A. They are your two parameters. So which one is going to be passing by value, which basically makes a copy, and which one is going to need to pass by reference to actually change the original location, or change the data in the original location. So here, is R being changed? Am I changing the value of R? No, I'm not. I'm just using the value of R and multiplying it by R, and then whatever result I get, I'm then changing A. So because I'm only using R, that only needs to be a copy, which means that would be passing by value, And A, because of this symbol here, the assignment operator, don't start with me now, pen. Because of the assignment operator, whatever the result is of pi r squared, it's going to change the value of that parameter because of the assignment operator. Hopefully that makes sense. I'll pause for a second. This one's being changed. We're only using the value of this one. So this one would be reference. Okay? All of this stuff down here, all of that is pointless. Doesn't have any real effect to what I'm creating. So you aren't changing R, but it's by val. Correct. I'm only using the value of R, which means I wouldn't need to send it in by reference because I don't need to change its value in the original location in memory. I use it by value because I only need a copy of it. I don't want anybody changing R accidentally, so I'll pass it by value. Then down here, at the bottom, explain the difference between a value and a reference parameter. Well, we know that this one's a copy and this one is the original memory address. So if you have a look at the answers here on the right hand side, we talked about these anyway, but that's not really what we're concerned with because that kind of stuff won't be on the exam. So you can have a read of that by all means. But here we've got by value, which was R, so we got that one right, and reference, which was A, we got that one right, and both must be correct for 1 mark. So we would have been awarded 1 mark for that. And down here, when you talk about a value parameter, a copy of the data is passed. It cannot be altered. And that has the advantage of unwanted side effects, like the value being changed by mistake. Remember, humans are stupid. Well, yeah. Reference. A copy of the memory address is passed. Therefore, the data in the calling environment is altered. So when it's called, it is changed, or it can be changed. Anyone got any questions on passing by value or passing by reference? Or about procedures or about functions? How many people we got? 23. Very good. Which part, Victoria? Go for it. There is a kind of 6-second delay on this. It'll be simpler. Yeah, it'll be way simpler, yeah. So a good definition of a procedure is there. So procedures are subroutines that do not return values. They normally calculate or display. And once they've been called and they've been executed, you return back to the code in the position where it was called. Like I said, I'll send these slides out later on onto the classrooms for you. But this one's a bit of an epic 400 odd slide mega revision presentation. I just keep adding to it. So Victoria, for you, if you just forget about everything else here, so let's say, right, well, forget about this, forget about this, forget about this, forget about this, forget about that, forget about that, forget about that, forget about all of that, and all of that. Hopefully you can see that this is my procedure. It's called find area. Okay? It's called find area. And it has two parameters. A parameter is something inside the brackets. If I had R, A, B, C in brackets, that procedure would have 4 parameters. I can't count. Oh my goodness. Now this only has 2 parameters. Okay? This one, I imagine, is the radius. And this one is probably the area. It's calculating the area of a circle, this is. Okay? That's all it's doing. But you don't even need to understand that. You don't even need to know that, to be honest. All you need to know is that in this line of code here, it says set A. As soon as I read the word set and I see this equals symbol here, this equal symbol means assignment. So whatever the calculation of this is, it's going to be put inside the A variable. And because of that, that means you're changing the value of A. And if you're changing the value of A, that means you're passing it by reference because you need to be able to change it in its original location in memory. Because you are just multiplying pi by r, you're not actually changing the r value. You're only using it. Therefore, you only need a copy of r, which is passing by value. So all you have to do is look at that and go which parameter is being changed and which parameter is not being changed. Hopefully that helps. Welcome, Mr. Coolbean. Okay. Now this kind of blurry screenshot, hopefully you can see that and you can read it. You wouldn't get something like this. You've got to be careful when you use different terminology because although it is a variable that is being passed in, you normally you reserve the term variable for things that you have declared in local and global scope. When they get passed in, you can say the variable is passed in as a parameter. You change your terminology when you put things in between the brackets. So normally we reserve the technical terminology for the two different things there, variables and parameters, try and keep them separate. I think so, Victoria, but that's not been decided yet. But I imagine so. Now, looking at this, you won't get an example of code like this. This is Visual Basic, isn't it? This is visualbasic.net. You'll be shown some pseudocode probably, and in the pseudocode, it'll probably ask you to show me where the variables are in local scope and show me where the variables are in global scope. So question to you, does anyone know which variables are, well, what line numbers is in local scope and which line numbers are in global scope? I'll just pause for a second or two. See if you can put the line numbers in the chat for the variables that are local and the variables that are in global scope. Okay, 5, 6, 7, 8, 9 and 10 are in global, and username and password is local. 5 and 10 is global. Okay. 14 and 15 are local. So what we have now then is in here, in the username part of 5 and 10, these are in global scope. Why are they in global scope? Because they're not inside these sub-procedures. And when you put things in global scope, normally they are at the top of your program. Things that are in global scope are accessible inside any sub-procedure. Global scope has some benefits, but it has some disadvantages as well. The benefit being that you can access it anywhere in your program or in any sub-procedure. The downside to that is that when you start your program, that memory for global scope remains taken up until you reach the end of your program. So that's what we refer to as the lifetime. The lifetime of a global variable is for the entire program until the program gets shut down. That's the only time that the memory will get relinquished or given up, is when the program is shut down. Whereas if you use local variables like 14 and 15, because it's inside the sub-procedure, you can only access username and password inside the sub-procedure. Okay, if I had another sub-procedure, I wouldn't be able to access these two here. Local scope is always better. It's better for security, it's better for memory allocation, because when the end of that procedure shuts, the memory that those local variables were taking up gets relinquished, and therefore it makes your system slightly faster. My real password is hotdog, yes. But don't tell anybody. Thank you. Okay, there are no more, looking at this, I don't think there's no more variables inside here. Attempts has been declared, that's been declared, that's been declared. Yeah, so you'll have to spot where global and local is. Zaki, I will talk about parameter passing when I timestamp the video. Yeah, I'll timestamp it. You can go back and have a look a little bit later on. There you go. So there's your definition for global and local scope. And don't forget, with both of these, you need to talk about the lifetime as well. So when these things die. Local dies when it hits the end of the procedure. Global dies when it hits the end of the program. Local scope. These are local variables that are only accessible by the subroutine they have been declared in. And global scope. These are global variables that are available in any subroutine throughout the program. Nice and straightforward. We're nearly done in that aspect. We've done parameter passing now. We did that one. Did modular programming. Yeah, fine. Good. Absolutely flying. Don't think we'll be here for 3 hours this time, which is good. Okay, systems analysis. Systems analysis is also referred to as the software development lifecycle, isn't it? Yeah, it is a long-winded process. Whoa. Now, you AS people will be starting your coursework next week. And it's going to be loads of fun. There's only one part of operating systems that's going to be in there. You can have a look at the main screen to see what they are. Now, the two types of approach that we take at A-level, there are more, disclaimer, there are more different approaches, but these are the two main ones that we cover at A-level, and that is a waterfall methodology and an agile methodology. And what is the process? What is the point of a software development lifecycle? Well, it's the process, isn't it? It's the process and steps that we go through as developers to produce high quality software solutions. We'll see if you produce high quality solutions next year, if you make it. Okay, waterfall and agile, they're the two. So here are a few different points on the waterfall methodology. I've done a lovely diagram to demonstrate what waterfall looks like. The reason why it's called waterfall is it trickles from one to the other, isn't it? Okay, that's what it does. So you start with problem definition, You do the feasibility study, you do your investigation, design, you build the thing, you test it, you document it, you maintain it, and then you evaluate it. Oh wow, look how clever you lot are finding it. Oh, it's good that, good emojis, well done. So, bullet points. The waterfall is a sequential process. It goes in sequence. So each one of those blue boxes are basically called stages or phases. So it goes from one to the other, to the other, to the other. And I've seen those referred to as milestones as well, so watch out for that. The design is drafted up front in detail and is not changed throughout the project. You agree the documentation with the stakeholder and that is it. You do not involve them again. Then you've got once one stage or phase is completed, we do not go back. We never go back. It is very rigid, the waterfall methodology. And then, if any stages are incorrect, the project is likely to fail due to the rigidness of the waterfall approach. As to your question down there, it's a very good point. However, you shouldn't do the software development lifecycle without knowing the approaches to it first. And that's why I've gone through Waterfall and Agile before I get actually stuck into the software development lifecycle. Plus, you'll be using it for your programming side coursework, which you'll start this week. And if you look in the AS spec, it is actually covered. Okay, so less communication between the client and the developer is needed as everything is agreed at the start of the project and throughout the analysis stage. So why do we include the customer in the analysis stage? Well, that's because we need to do different investigation. So you need to do different investigations with them, such as interviews, document collection, that sort of stuff. Well, again, another good question. In an ideal world, you would be able to go back. You would be able to go back. But because of the time frame, every single stage is carefully time-stamped and you've got deadlines. So if you go back, then you run the risk of not completing your project and therefore it being deemed a failure or you having to incur more costs because it's gone over the deadline. The coursework is for... It's for your whole 2-year course, actually. You start it in the second year, but it's for your overall 2-year grade. Yeah, Zach is an absolute pro at it. I'm sure he'll be able to comment. So there is a heavy focus on rigid documentation. That's a benefit, believe it or not. It's a benefit because legally, every single stage is documented. So if your stakeholder decides to turn against you and... take you to court for whatever reason, then yeah, it's heavily documented. So if you compare this, I mean, I don't like the waterfall approach, I'll be honest with you, but the agile methodology is better. I prefer developing in an agile methodology because there is an incremental approach. So you can do small stages at a time and you can repeat things over and over again if you want to, but you do run the risk of running over your deadlines. Developers start with simple project design and requirements and build on it as they progress through the project. But that means that you take into account a lot of feedback from the stakeholder or the customer. And the analysis informs the design, and the design informs further analysis, and that's what needs to be taken into account. So changes can be made after each phase of the development, and we call them sprints. So you do a little bit of development, you then show the stakeholder, they give you some feedback, you go and redevelop and come back until they're happy. But you run the risk of the stakeholder talking about changes and just changing things for changing its sake, and then you start to get something called project creep. That's where your project runs away from you and you miss all the deadlines. Zaki knows about missing deadlines, don't you, Zaki? Then you've got stronger communication between the client and the developer, because the clients are involved all the way through the project. Plenty of feedback, but it is a lot more onus, a lot more flexibility on the software developer. Thank you, Max. So they're the two approaches. So then, those two approaches take you through the whole project. So looking at this here, you got the problem definition, feasibility, analysis, design, build, test, document, maintain, evaluation. So we're going to start with the feasibility study. If a project fails to meet the time and financial restrictions, it is considered to be a failure, even if you deliver it. So if you deliver it after time and if you have gone over budget, then technically your project is a failure regardless. Nobody wants that. So when deciding on how feasible a new system is, a number of factors need to be taken into consideration. So, a feasibility study is carried out because we need to know a number of things before we even put pen to paper. And feasibility studies are carried out not just in software development, but in most organizations in the world. We need to ensure that any project is going to be worth our time and energy. So is it technically practical to do? Do we have the technology? Is it even, right, let's go to Mars. Okay, fine, but can it actually be done? Well, speak to Elon. Will it be cost effective to our business? Will we make enough profit out of this for our business to survive? And believe it or not, that is a large reason, it is why government systems fail. Because people want government contracts because they pay very well, but people often promise the world and don't deliver. Cough, cough, COVID app. I'm just saying. Yep, sell your Dogecoin. So, will it be cost effective to our business? Can it be done in the proposed timescale? We have 12 months to complete this. Yeah, but we've got 6 other projects on. Will we be able to do it? Can it be done on budget? Do you need to hire more people? Will that impact your amount of profit? Do we need a bigger budget, etc., etc.? You could say that. Not all firms focus on profit. Yeah, but if you don't make a profit, you're never going to survive. You could be a non-for-profit software development company. Good luck to you. So, if all is good, then we decide to progress with the project. And then, once you've progressed with the project, done your feasibility study, you then look at your analysis stage, which is also referred to as your investigation. An analysis is a really important part of the process because you're finding out exactly what the system will entail, what it needs to do, by employing a number of fact-finding methods. And there's 4 that you need to know about. But getting this right is so important because it's going to impact your design. And then after your design, it's going to impact your prototype. And after your prototype, it's going to affect your software development and your testing and your evaluation, etc. If you get it wrong, potentially it could lead to delays on each part of the project. And then again, costs can escalate. And before you know it, you're paying for this system rather than you being paid for it. So here we are then. 4 fact-finding methods. We've got an observation, questionnaire, document collection, and an interview. The 4 main methods that you need to know for A-level. And for each of these, you need to know the advantages and the disadvantages for each one. So let's jump straight into it. So an observation then. It's where the analyst shadows employees of the business for a period of time, making notes on how they do their job. They observe employees in their natural environment to see exactly how the business works. So you literally sit with somebody using the system and you write things down. Okay? So sometimes when you do things every day and you start to bypass things and just forget about things being an issue, etc. But an outsider will notice that a lot more than you will. Now, the issue with this is that some people feel threatened when they're being watched or observed. Again, the example I use is when you watch a teacher being observed by another teacher or by someone from senior leadership, they start to behave a lot in a bit of a weird way. They change the lessons. Like, I've been doing lessons the same way for years, and then all of a sudden someone walks in the room and we're doing some fantastic, amazing lesson. That's what happens when you observe. It makes people nervous. So you can pick up parts of the system that are not immediately obvious to the customer, and that you can confirm information gathered through different fact-finding methods. So you can say, I saw this, was that confirmed in the document collection? Yes, it was or not. Then another disadvantage there is no guarantee that some of the more suitable parts of the system will show up during the observation period. They become nicer. No comment. If you ever see me getting observed, I am exactly the same niceness. Okay, questionnaires, as good as they are, questionnaires are actually harder to make than you think. So they're quite common. The good thing is you can give loads of them out at one time, but it doesn't mean that you'll always get everything back in. So when you design a questionnaire, you need knowledge of the system that's going to be built. You're going to give out your questionnaire to a range of people. And what you need to do is you need to have an understanding of the system before you actually do the questionnaire, because you need to target the questions so you can get decent information back. If you just ask general questions, you're not going to get very good response back. It's also important to restrict the number of choices available for each question, as some people may give unexpected responses, or they might just slate the system because they don't like it, rather than giving you actual problems about the current system that you can improve and fix on. Now, again, advantages and disadvantages. We'll start with the advantages, and these can be given to a large number of people at once. So what you'll be doing is, in your coursework for your discussion sections, you'll be creating a feedback form. I know it's not a questionnaire, but it's similar. But you'll give out your feedback form. You can do that on Google Forms. You can email it out to people. It's electronic, you can't lose it. People can't just chuck it in the bin, that sort of stuff. And that means you might even get a large number of different opinions. But they are hard to create and design properly, believe it or not. And not all questions, not all questionnaires actually get sent out will be completed, because people will just ignore it or delete your email because they think it's spam. You might think the same to my emails. Just put them in the bin because they're spam. Document collection. Don't ask me why this picture always comes to mind. But believe it or not, that's what people do. They sit down and they sift through documents. So during document collection, the analyst gathers any business documents that relate to the new system to be constructed. And these include orders, so things like invoices, financial records, and any other documents that might be used on a day-to-day basis get used. So anything relevant, you'll get that information. But the issue here is GDPR. Normally, when you ask for documents, you might get the documents, but they might be redacted. So certain parts of the documents have been basically blacked out. You can't see them because to protect GDPR resources. Okay. So documents in use in the current system are a good guide. And the reason why they're a good guide is because people can't lie. The results are the results. The statistics are the statistics. You cannot lie about it. Oh, that says number one twice there. How strange. The data they use and what will need to be stored by the new system will be on those documents. And when you're developing, you create something called a data dictionary. And that information from documents will help with the creation of a data dictionary. And the analyst can get a very good understanding of the business processes by following the trail of documents and seeing how the data flows from start to finish. And the analyst might even make diagrams like Jackson's structured programming diagrams and data flow diagrams and things like that. So here we go. Advantages and disadvantages. Documents are reliable. They show most of the data stored in the system. Document trails help support the analyst's picture of the business processes. But the problem is documents give a limited view of the system, and they don't say how they were created in the first place. So you have to make up the process to create the same data, but you'll use other investigation methods to help you along the way to do that. Documents may contain sensitive information, and there may be restrictions on seeing them, and that's what I was talking about before about the redacted part of that. And finally, the interview. I don't know if you've done an interview before. You might do an interview in the near future. You might have, a member of Oldham Sixth Form might have come to your school to conduct an interview, or they might have done it virtually. So interviews are exactly what you think. Somebody sits down and asks you direct questions. But it's mostly, this is where most analysis starts. They pick some key stakeholders like the CEO of the company, a manager that uses the system or something like that. And then they ask them targeted questions about the current and new system. So what's bad about the current system? What do you want the new system to do? Etc, etc. And the reason why you can get a large amount of information in a very short period of time is because you can ask follow-up questions. So you might pose a question to someone, they might answer it, and you might go, yeah, but in addition to that, well, what does that do then? And they go, oh yeah, what does this? Well, where did that come from? Oh, it came from there, and that's how we got it. Okay, yeah, fine. So that's why we normally start with this first, interviews first, then we delve into all the other investigation techniques. If you've ever done an interview, they are quite time consuming. So let's have a look then at the advantages and disadvantages of that. Most of the time that I've interviewed people, they are not the same person that you see outside of an interview. People get very nervous, even mildly hostile. They've never been hostile to me, but they have been nervous. And when you're nervous, you don't tend to answer the questions as accurately as what you would normally do in a non-interview setting. So large amounts of information can be gathered because you can respond to people's queries and answers. Interviews produce detailed responses about key parts of the system, and normally what we do is we normally record them. We normally get a little microphone and we record it rather than writing it down and type it up later on so we don't miss anything. Disadvantages are that it is time consuming, so only a limited number of people can be interviewed in the first place, and interviewees may not be fully truthful, so their responses need to be verified. People like to lie, even if you're just asking them general questions. Don't ask me why. I am 100% truthful. Yes, yes, yes. Zaki, I can call you out here. Your coursework is pathetic. Just saying. It's the way it is. You got to live with the facts. Now, let's just go back here. We don't need to do requirements because that's not going to be on there. But we need to look at testing. Testing. So as you move through the software development lifecycle, you cover the investigation, you've completed a design, then you prototype, then you do some kind of refinement on that and get some feedback. Then you develop the entire project, and after you've done that, then you test it. So if you release untested or poorly tested code, then it tends to result in unstable applications and the wrong outputs. And that can do a number of things. It can damage your reputation. But normally, if it damages your reputation, you've got no chance, because software development normally works on reviews and the showcasing of your work. So apparently, if one person doesn't enjoy what you've done, they normally tell 19 other people on average. On average. I don't know if that's true or not, but hey, it's what it is. Nobody wants dissatisfied customers because they won't come back ever again. Now, the testing, it's important to point out here, believe it or not, I've had unconscious bias training. Yes, unconscious bias training, because I will write some code and I think it's great. And you would, because you made it. And it's the same thing that you write a paragraph in English, you might check it for spelling and grammar, but you might not spot all the mistakes because subconsciously you think that it's amazing. I don't know why you'd write anything in English. Don't get me started about English as a subject. So most developers find it very difficult to find bugs in their own programs. And in industry, good practice is to do paired programming, where you'd sit with another person and they would program and somebody else is sat next to you watching what you're doing. And they would call out your errors, your bugs, the things that you're doing. And the reason why we find it very difficult to test is not because the testing is complex, it's just for the fact that you just make subconscious assumptions that your software will work. Because you think you're the best, but you're not. Sorry to say. So other people may take a very different approach to testing or using your software, and it can result in them finding bugs or problems that the developer didn't. And this is why developers pass their code onto another person to test. And if you've got the capacity for an in-house testing team, even better. So it's common to use more than one test to actually test software. And the better you test your software, the more robust it's going to be and the less errors it's going to have. And we've all seen things in the news about things like Cyberpunk, I think that's what it's called, sending that out when it wasn't even finished, really. It was pathetic. I don't know. The company reputation has been damaged. So problems found later on in the system analysis lifecycle are harder and more expensive to fix the further down the line they go. So let's have a look at a couple of different types of testing. We've got white box, unit testing, black box testing, alpha, beta testing, end user testing, and user acceptance testing. So they're the ones that we need to focus on, and I'm going to give you a quick recap on all of these. If you've got specific questions about any of those specific tests, put them in the chat as we're going through and I'll answer your questions as I go along. So white box or glass box testing is where the structure of the code itself is being tested, and it requires knowledge of how the code was developed. So who is actually going to do that testing if it requires knowledge, people? Well, the developer. Okay? And the reason why the developer does it, because they need to know every different pathway through the system. Whether it's an if statement, a loop of some kind, some nested ifs, some procedural calls, functions, recursive algorithms, the developer themselves would do it. And white box testing is done basically at the start of the program. Very early on, it's very buggy at this point, but that's who does the white box testing. Unit tests. The unit tests are normally created so that things can be automated. Testing can be automated slightly more. And it's all about testing code that's working as expected. So unit tests run the code to be tested with various sets of inputs, usually using an automated script. And the reason why we actually use unit tests and automated tests is something called regression testing. I'll talk about that in a second, but that's why we use them. So regression testing is when you're moving through your program and you're testing different parts of it and you are changing parts to make it better or make it work, then regression testing is looking back to make sure that everything you've tested previously works now you've made those new changes. And if you don't do that, you're going to have a nightmare. because you might think you've fixed all the errors and then you run your program at the end and you've got a load of new errors because you've been changing stuff throughout your program. So if changes made downstream introduce bugs, this will be picked up by the unit tests. And they're written by the developer under the guidance of the methodology being employed, so whether that's waterfall or agile in our case. For your coursework, you don't have to write unit tests, you lucky, lucky people. All the data for all the tests should be valid, invalid, extreme valid or invalid, and erroneous data types. And that's just so we can test that our code is actually going to work. Right, so black box testing. This can be done off-site. And again, this is just straight test script testing. So you get a test script together, you give it to someone external, and they just carry out the testing. There is no knowledge of the code needed because the only thing we're testing here is the outputs. So we take valid, invalid, and extreme input data, we put it in to our system, and it should spit out a result. The person should check with the data input that the output is produced. If it's not produced, we send it back to the developers, and then they can improve it. So again, if you've got an in-house testing team, give it to them to do, or you can buy in testing teams or send it off to someone to be tested. So there we go, not done by people who are not directly involved in the development. Okay, system testers are very methodical. They'll go from start to finish and they will not skip a test and they will not rush a test, because we're trying to highlight and iron out as many bugs as possible. It has a lot of structure on a test script, and normally there's hundreds of tests to do on your system. And then all we do is they submit the test script back to the developers, and they will fix any issues that came out in the black box testing. These ones, students tend to be pretty comfortable with these, and that's because they've usually taken part in beta trials already with games and things like that. So testing is carried out in phases and by different people. So the two most obvious are alpha and beta testing, and these terms relate to an alpha test. These terms relate to alpha and beta builds of the software. So the first thing is, if you're asked about these in exams, you need to be able to explain who is doing these tests, why they're being done, and what the reason is and what stage of the life cycle they are actually being carried out. So for all of the tests, you need to be able to explain that for the exams. So alpha tests are not usually stable. They normally lack functionality or may not even work at all. And we never, ever, 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 ever let the customer see the program at this stage, because they'll panic because nothing works. Well, not many things work anyway. So it's carried out by the developer themselves, or again, their in-house testing team. And the system contains lots of bugs. So do not ever, ever give this to the customer, ever. Beta testing, okay. It's more complete. It's almost there. And it's done later on in the development life cycle. So it's more stable, and therefore we can allow other people to have a go and find bugs. And nowadays, we're smart enough to put analytics on our systems where it would automatically report crashes back to the developers. So for things like Windows, if you get a screen that says not responding, and it'll say send your data to Windows, then you click OK, and it'll send off a report back to them to explain what happened. So you can give it to a customer or a limited amount of end users. Windows are really good at this. They will give out, whenever they get a new operating system, like Windows 10, they'll give it out for free in the beta version. And then everybody will download it thinking they've got a free copy of Windows, and it's actually buggy as. So all I do is I wait until the beta is going off its trial, and I wait till like the last day and I download it then, because normally all the things have been patched by that point. Yeah, game companies release games, and that's just for feedback. That is more like a popularity thing, but there is still bugs in them. But normally you have to agree to send off the test logs. Okay, the customer carries out beta testing as if they were using the code in a live situation. That's where your games come in and things like that. And any faults found are returned back. I'm surprised they send out alpha tests, I really am. But hey, each to their own. Now once you've done those tests, you're now at the end of all your testing. You've developed the solution and you're done. So you've got something called end user testing. Have a guess what happens at end user testing. So this ensures that the system meets all the requirements, but with a greater focus on usability for the end user. So things like, is the interface appropriate for the end user? Does it perform well? And that's where things like, your games go out there, see how people react to the game. Do you need a bit more time to change some stuff? What's the general response, etc. But usability testing seeks to verify that the implementation approach works for the user base. So are we aiming for 16 to 25-year-olds? Is that the majority of people that have downloaded the game? Are they using it for the right purpose? How long are they playing on it for? Etc, etc. So end user testing and user acceptance testing are two different things. So this is more about the end user. Acceptance testing is more about the stakeholder, the person paying for the software. And acceptance testing is the final phase of testing. And we're checking to see if the thing that you've created has met all the specification. Have you ticked off all the requirements on the spec? And if you have, give me some cash. Pay up, because it's time to pay. So that's what acceptance testing is. And I've seen people argue. I even almost saw a fight over acceptance testing, because some people agreed that it was doing the thing that it was supposed to be doing. Some people agreed that it was not doing the thing, and it got heated and arguments happened, because this is the crunch point for your project being a success and finishing or not. All good fun. So at that stage, you're ready for payment if you've passed all of the requirement specifications. So your program will go in under a range of different tests. It might be performance related tests to see how fast it boots up, how long it takes to load a game, for example, or it might even be, does the interface work? Does it function as expected? Does it add up all the points? And does it display a leaderboard? And can you use the online version? And there's millions of different requirements. And that's why these teams get a massive. No, evaluation is what we do. We evaluate what we've done. So we look at things like, how can we improve? How can we be better? What was the development like? That's what the evaluation is all about. This is still the end of testing. Okay. So, with that, what I'll do is I will aim to do compilers, interpreters, compilation process, and then we'll see where we're at. Okay, so we'll hang in there for a little bit more, people. We're nearly done. How long have we been going for now? An hour and a half. All good fun. You said computer science wasn't fun, hey? Okie dokie, right. Here we are. Translation programs. To translate is to convert from one thing to another. There are three forms of translators: compilers, interpreters, and assemblers. None of the above, hi. They're both terrible. Matthew, I don't think you did. But whatever you want to believe. So compilers, interpreters, and assemblers. Compilers do something different than interpreters, and obviously assemblers are kind of on their own in the cold. Nobody really cares about them because not many people write in assembly anymore unless you love electronics. Okay, so a compiler. This is the one where you're going to go into depth on this one. So you're going to go through the compilation process on this one. But compilers convert source code. So you write in source code, people, and you convert your high-level source code into machine code using a compiler. And your IDE, your integrated development environment, does that for you. You just blink and it's converted into machine code. How nice. When you compile, you convert your source code into a standalone executable file, an exe file. So if you go into your Visual Studio project, go into your debug folder, go into your bin folder, whichever way around it is, and then have a look. Your exes will be in there. Every time you click that little start button on Visual Studio, you compile your programs. Yes. So that standalone executable file needs no more further compilation. Because it's easier to get higher marks. That's one of the reasons. Especially for projects. But still, all the constructs are the same in all languages, so it doesn't really matter what language you're actually writing, to be honest. So, in there, a program is compiled once but can be run many times. And then when you've compiled something, it actually protects the intellectual property because everything is converted into machine code. You can't turn it backwards. So it's not reversible. Also, looking at an interpreter, think about the platform. When you compile a program, it is platform specific. So if I compile my VB program, it will then turn into an exe specifically for Windows machines. Having an interpreter installed gets rid of that disadvantage. So an interpreter handles the code very differently. It converts each line of code and it gets translated line by line. The interpreter takes the first line of source code and translates it and executes it before moving on to the next. And that's good for testing, but it's not good for your intellectual property of your code because people can see what's going on. Any machine code produced while the interpreter is running is not saved. So every single time you run this, you have to run line by line again, which can slow down your interpretation of a program. So the interpreter must interpret the code every time the user wishes to run it. What a pain. What a pain. So in order to be able to run an interpreted language, you must have an interpreter installed. One of the most common ones that we see in the world is the Python idle, IDLE. It's just a script program, but it can be run on anything. A Mac, Windows, Linux machine, doesn't matter, it can run it. So that removes the barrier for being architecture specific. Just install an interpreter and off you go. Unfortunately, you can't do Visual Basic.NET for on a Mac or on Linux unless you get a virtual machine installed. Okay, so interpreters, the advantages. Source code has to be written only once and then it can be run on any computer with an interpreter. You can easily inspect the contents of variables, which is better for testing. You can test code much more effectively as well as being able to test single lines of code. And finally, code can be run on many different types of computers, which is good. Much better. Okay. There we are. So disadvantages, you must have an interpreter running on the computer in order to be able to run the program. A source code must be interpreted each time. Interpreted programs can sometimes run slowly, and you have to rely on the interpreter for machine level optimizations rather than programming them yourself. So your interpreter has to handle all the optimization for the architecture that you are trying to run your program on. Have a think about what that means. We'll talk about optimization in a minute. But developers can view the source code, which means they could lose their intellectual property to develop their own software. So if you compare these two, which might be what you're expected to do in an exam, will be a decent 6 to 8 marker to compare these. You would say, well, think about the source code. A compiler, the source code is hidden. An interpreter, there is an intellectual property risk. Multiple platforms, a compiler is specific to one platform. An interpreter, any, providing that you've got the interpreter installed. How easy is it to distribute a compiled program? Very easy is the answer. It can be put on CDs, internet, it can be sent on Google Drive, we can put it on a USB stick. It's very easy to transport around. An interpreted system, so we can send it, no problem, but wherever the destination is, whatever computer you're running it on, you need to have the interpreter installed. And you also need all the libraries as well that you're going to use for that program. Advantages and disadvantages for all of the translation? No. Don't need to know them all, but it would be good to be able to compare them. So the Outcast, the assembly language on its own, not friends with compilers and interpreters. Assembly language is a lower level code. Lower level meaning lower or closer to the hardware. So assembly language is a step above machine code, allowing the programmer to write using something called mnemonics. And mnemonics are those things down there: LDA, add, STA, halt, HLT there. Okay, load at the address, store at the address, etc., etc. Now, all you need to know about assembly language at this point is you have what we call a one-to-one mapping with machine code instructions. Okay, one-to-one mapping with machine code instructions. So in that table, you can see that, for example, let's take location 0 has got an LDA command 09. So load at the address 009, but its machine code version is 00101001. And that's unique. So the LDA command will have its own machine code instruction, and that is a one-to-one mapping. And it just means it's quite fast, that's all. Because it gets converted into machine code, it's lower, gets converted into machine code faster, therefore it can be run faster. And that's why things like your washing machine, for example, it would be programmed in assembly language because it needs to be very quick. It's very simple but quick. You don't need a graphic user interface for your washing machine, I don't think. So when you assemble machine code, assemble into machine code, writing machine code is very time consuming. It's prone to errors as well. So we don't do it. And that's why assembly came around, really. But when converting assembly to machine code, we use an assembler, which is a form of translator, as we saw before. And when we convert assembly code, it's known as assembling rather than compiling or interpreting. So these are the different paths you can have. The first one being, if you write source code, you can put it on a compiler or put it on an interpreter. If you put it on an interpreter, it'll go straight into machine code and off you go, line by line. With a compiler, it'll turn your code from source code into object code. It will bring in the libraries, so any external libraries you've used to help you program. It links them together, and then it puts it into machine code, and you're good to go. Never has to be compiled again, it's done. But on top of that, you can have something called intermediate code, which is like a partially compiled program. And then if you stick that into an interpreter virtual machine, you can then use that as like your interpreter. So when I used to write Visual Basic programs, I only had a Mac at the time. I would use a virtual machine, which is a computer inside another computer, and I would basically trick the computer into thinking it was a Windows machine, and then it would compile. But I had to use intermediate code to actually do that. And what a pain it was. I do not recommend it to anybody, ever. What a pain. So now I only use virtual machines for running viruses in a controlled environment. That's all. Okay. Last thing. The last thing. Principal stages of the compilation process. Okay, those 5 things there, we need to be able to explain. This is the diagram that you've all seen. I hope you've all seen it. And you need to basically explain your way through it. The things in the purple rectangle, rounded rectangle looking things, we don't need to know about them for this exam. But we need to know about lexical, syntax, semantic, machine code generation, optimization, and linking. How old do you think I am? Anyway, so there is some code, and in the first stage of the compilation process in lexical analysis, we look at the code and we basically do a few things. We start with taking all the white space off, and unneeded punctuation, code comments, etc. all get stripped off your code. We then turn the code into something called tokens. So we turn the code into something like this. We break it up into tokens. And then we say which ones are reserved and which ones are made by us. So if statements are reserved words, score is a variable made by me, greater than symbol there, that is a relational operator. 40 was created by me, blah, 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 blah. All that good stuff. It all gets split up. If there's any problems here, we produce an error. And if you're talking about the stages, at any stage of the any stage of the compilation process, if we have an error, you can say that and get yourself a mark. So here we've got a simple error is produced. It will stop the compilation process. There's no point in going further on in the compilation process if you have an error at any stage of the compilation process. So after you've tokenized and broken down, took all the white space off and all the punctuation, all the comments, then we get to syntax analysis. We create something called a symbol table or a dictionary, and that's where we basically put our reserved words and our identifiers, which are the words we create, into tables. And we assign them a hex token. So a hexadecimal token gets assigned to it. And we make sure that what we've written matches the grammar of the language. So does it actually fit in our language? So do we use the word print? So if you write print in Python, all lowercase, it'll be fine. If you write uppercase P, it will kick off. And that comes into semantic analysis a little bit later on as well. But syntax trees are generated. You don't need to know what they are at this stage at AS, but you will at A2. If it asks about one stage, Victoria, of the compilation process, it won't be any more than three or four marks. So if it doesn't fit the grammar, it will produce an error. Then we look at semantic analysis. Checks that all the variables we're using have been declared and have been used. And have a guess what happens when we don't use a variable. If we're not using it or got nothing assigned to it, we stick it in the bin. We don't use it. It's taking up memory for no reason whatsoever. And then we check that the real values are not being stored as integers, for example, or strings don't have numbers and all that good stuff. We check to make sure that our variables are being used properly. But normally, your IDE, your integrated development environment, gets all this for you anyway before you compile, before you click that button. We check the operation is legal. So none of this stuff, believe it or not, I still see this. I still see this all the time. People will go, what is that? What symbol is that? What on earth? Also, I see this as well. What on earth? You Python programming people, in Visual Basic, it's this symbol. That is the same as that one. Depends on your language. Python, Visual Basic, etc. But make sure that you've got a legal operation. Greater than or equal to. Less than or equal to. Not equal to. Etc. etc. So make sure that's all correct before moving on. Okay? So if you don't stick to the rules, you get told off and it produces an error. Okay, or you can, yeah, right, fine, that's a funky not equal to. So at any point, you know, if your syntax is incorrect, you will get a syntax error and it doesn't match any of the rules. It will tell you about it. Only when the code has gone through all them checks and it is happy, will it build a final syntax tree and then turn your code into machine code. Only when all checks have passed. Now, machine code generation occurs once the abstract syntax tree has been created. So, the point of machine code generation is to convert the elements on the little syntax tree. So again, you don't need to know what it is, but I'll give you a little demonstration. That's what an abstract syntax tree looks like. Let's do... Okay, so what it'll do is it can build up equations, it can build up machine code, it can build up long strings of code, etc. based on your syntax tree. We don't need to know about that until next year anyway. But then, once it's done that, it'll allocate registers to each one of these nodes on the tree here and minimize memory access. And then we optimize. And optimize plays a massive part in the compilation process because you're all terrible, terrible programmers. And I'll show you why in a second. There he is. When you write code, you write it in such an inefficient way, so bad that the program, the compiler, will make your code better for you without you even realizing. And what that's doing is it's creating a generation of programmers that just don't care about their code. If you're working for, I don't know, chip manufacturers, NVIDIA, graphics card people, whatever, you will be expected to write code in a mathematically efficient way. But when you're making general programs, nobody cares. Nobody cares. So most programmers write code very inefficiently and they don't care. The higher the level, the more sloppy code. So Python, Visual Basic, C#, C++, whatever, those are high-level languages. People write sloppy code and your program fixes it for you. So most programmers don't know or even care that their code is inefficient. They'll just keep writing. As long as it compiles, you're all at this stage now where as long as it works and it produces something, it doesn't matter how many lines of code you've written or in what order. As long as it works, you are as long as it works programmers at the moment. Many compilers perform a number of optimizations for the developer. And one way to speed up a program is to limit the number of jumps it has to do. So if you're aware of hardware and communication, CPU, fetch, decode, execute, jumping, then you'll understand why that is a benefit. limiting the number of jumps. Now, correct. Reyes, I won't expect anything less from you. Now, the goal of optimization is to achieve the required output of the program. So although you produce the output of the program, optimization, its goal is to achieve the same output, but more efficient. Its goal is to increase the speed of the program altogether and decrease the demand on resources. So it's trying to remove any extra memory locations that you've used that don't need to be. And it might even force in there iteration or recursion. You don't need to know about that until next year, but iteration especially. And it tries to do all that without delaying the overall compilation process. So these optimizations happen in a fraction of a second without you even knowing. So achieve the required output, increase the speed, decrease the demand on resources, but don't delay the overall compilation process. We don't need to look at execution and syntax errors. So we can go back home, if it lets me. Nope, it's not letting me. Great. There we are. Okay. At this point, people, we've been through all of the main parts on the topic list, which we didn't cover in the last revision session. So algorithms and logical operations, we covered them in the last revision live stream. Everything else we've covered now, that was new. So, a couple of things before we actually do part ways. Don't forget your test is on Monday, which is tomorrow. And it is in room 242, which is the digital hub, which is the large room at the end of the corridor, unless you are my L group, period 2. You are in the same maths classroom that we've started to do our lessons in now. Please turn up on time, because as soon as you sit down, the exam will begin. Make sure you bring a pen. That's always important. And remember, this will be used as a part of your internal assessment. Overall grading for this year for AS. And as always, I wish you all the best of luck. Thank you for joining me on this. I know it's taken up some of your Sunday. I put this on because people requested it, and I hope that it has helped you out, no doubt. I will send out these slides, and I will timestamp the video. And unless people have got any more questions, have a great evening, and I'm sure I'll see you tomorrow. Thank you, no problem. See you later. Have a good evening. No problem. Didn't even know half of these people were on, but it's good to see you all.